This is page 876, our last one for lesson 3, combinations, permutations, and then how they're useful in probability. Consider the number 12,378, like the last one of our last video. Use any 3 digits. What is the probability of making a 3-digit number whose value is greater than 700? Well, for the 3-digit number to be greater than 700, the first digit must be either the 7 or the 8, and there's just 2 options that can do that. And if you make an organized list of all of the possible arrangements where the numbers that we can make from 1, 2, 3, 7, and 8 are bigger than 700, here they are. There's 24 of them. Let's confirm that with the counting principle. You got 2 choices for what the first number can be, a 7 or an 8. But once you pick it, then all of the other numbers are possible for you to use. It's just you picked one from 5. So in the second choice, you now have 4. And then after you've picked 2 of the numbers, you only have 3 remaining. So counting principle, multiplying up by all of our options, 2 times 4 times 3, 24. There are 24 total arrangements of numbers where they're bigger than 700. However, in the scheme of all possible 3-digit combinations from those 5 numbers, then order matters. We have a permutation, so it's 5 permute 3. 5 permute 3 is 5 factorial over 2 factorial. 5 factorial is 120. 2 factorial is 2. So this is 120 divided by 2. And if you think, LeBron, I didn't follow that, you should give me some more details. Let's go to the calculator. NPR 5 permute 3, 60. Or the fraction control divide 5 factorial over 2 factorial, 60. So now to figure out the probability of what we've got going on in this problem, it's 24 divided by 60. 24, we'll come back here, 24 divided by 60. 2/5? Yeah, okay, 2/5 is fine, but I want that as a percentage. So if I multiply everything by 20, I get 40 out of 100. Let's just show it. Let's just go 2/5 as a decimal times 100. 40%. There is a 40% chance, or you can determine a 3-digit number whose digits make it greater than 700 40% of the time. Now, this last part, pause. But I think I should do like a slow reveal, if you don't mind, like a little, like, hey, what's that all about? Nah, there it is. What sort of information do we get from our formulas? 3A. NCR, use this formula to compute the number of combinations of R letters from N choices. N over K factorial H factorial. Think back to where we saw that in the lessons. Use this formula to calculate the number of permutations of N elements where there are K copies of one element and H copies of another. 3C. NPR. Use this permutation formula to compute the number of arrangements of R things out of N total things. How about 3D? N factorial over K factorial. This is a permutation where in the permutation of N elements, there are K copies of one element. And we don't need to keep the number of elements separate from each other, so divide by K factorial. 3E. N minus 1 factorial, that's for circular permutation. If you have 4 people in an officer position and you want to put those 4 officers into some sort of circular order, there is 4 minus 1 factorial ways to rearrange them. And we studied that in one of these pages. And last of all, F, N times N minus 1 times N minus 2 times N minus 3 times ... all the way down to 3, 2, 1. That's N factorial. That's the total number of arrangements of N things. Thank you for watching. This is a very beefy lesson, and you've stuck with it all the way through, so kudos to you. I'll see you in lesson 4 coming up next.